Alright, so if we're finding a difference quotient here, then the first thing I'm going to do is I'm going to simplify this for myself. This is our difference quotient, because it's dividing. That's what quotient means. So this is our difference quotient. I'm going to make it easier for myself and just break it down into parts. So I'm going to do part A first, which is f of x plus h. Whenever we have f of x plus h, it means everywhere that there's an x, I need to put in x plus h. You're going to see this gets a little difficult. If I plug x plus h in first, I'm going to have to square that, so I'm going to have to FOIL that. So if I FOIL x plus h squared, that's the same as x plus h times x plus h. Now the fact that it's squared means that there's a special relationship that we have here. So we can do x squared plus 2hx plus h squared. And that's what this part is whenever we actually square it or FOIL it out. So we do x times x plus x times h plus x times h. So that's where my 2hx's come from. And then h times h, which gives us h squared. And then it's still minus x plus 2. So this is my final answer for that portion of the problem. Part A is done. Part B is f of x plus h minus f of x. So I'm taking this first part of the problem that I just accomplished and I'm putting it in with just f of x. So I'm subtracting f of x from that. So I have x squared plus 2hx plus h squared minus x plus 2, and then it's minus my original equation. Now I have to distribute this negative to all three terms. That gives me x squared plus 2hx plus h squared minus x plus 2 minus x squared plus x minus 2. Now I can combine my like terms here. I have x squared minus x squared, so those cancel. I have negative x plus x, those cancel. And I have 2 minus 2, those cancel. So all I'm left with is 2hx plus h squared. Now for part C, I'm doing all of that on the top over h. So that's 2hx plus h squared over h, which really means 2hx over h plus h squared over h. And now I have 2hx over h, so those h's cancel. I have h squared, which is basically h times h divided by h. So that cancels with one of those. And my final answer is 2x plus h. Nah, it's easy. Okay, the other way we could look at this is by factoring the top out. Since I have an h in both of these, I can pull an h out in front. So that's h times 2x plus h, and then this is over h, so I can cancel my h out there. It gives me the same thing, 2x plus h. Just a different way to look at it, different way to approach it. Still gives you the same answer. But, all right. Functions that are defined by equations. Equations in two variables can be used to define functions. However, not every equation in two variables represents a function. So example 5 is going to be determining if an equation defines a function. So if I'm looking at this equation trying to determine if it gives us a function, then the first thing I think we should do is solve for y. So I need to get y by itself. So I'm going to get everything on the other side. So I'm going to subtract the 4x over, subtract 5 over. Should be a 5. So it gives me negative 2y to the third equals negative 4x minus 5. And I divide by negative 2. Give me y to the third equals negative, let's just leave it as it is. Negative 4x divided by negative 2, that gives me a positive 2x. And then up here, 5 divided by 2, I'm just going to leave that as 5 halves. Then to get rid of this cubed, I take the cube root. And now whenever I look at this, I have y equals the cubed root of 2x plus 5 over 2. So basically I need to ask myself, is this going to give me more than one solution if I plug in x in? And I can choose any x, and if I plug any x in, is it going to give me more than one solution? Well, there's a good way to check it, and that would be just to graph it. So when we go to Desmos, in order to figure this out, how to put a cubed root in, if I go to Functions, and then over to MISC or Miscellaneous, there's an nth root thing, and I can type in a 3, and now I just enter my equation at 2x minus 5 over 2. So when I look at this, for every x, is there more than one y? So if I go over to 1.25, if I draw a vertical line, is it crossing at more than one point here? The answer is no. Even though it looks like it might be a vertical line, even as I continue to zoom in on it, it looks like it might be vertical. But if I put in a 1.25 into the equation, it's only going to come up as one answer, which would be 0. Like if I go as close as I can to 1.25, you see it's still 1.2501, but it's 0.0585. So nothing is going to give me 0 again outside of the 1.25. So this one would be a function. All right, a student, the only student who shows up to class, pointed out to me that I put a minus in instead of a plus, so that actually moves it to the left side. It doesn't change our answer, though. It still is a function because it only crosses at this one point at a time. So it still would be a function. Thanks for pointing that out, anonymous student. All right, let's try to do the next one. Where it's y squared minus x plus 1 equals 0. So in order to do this one, I'm following the same policy. I want to get y by itself. So I'm actually going to add x over and subtract 1 over to the other side. It's going to be y squared equals x minus 1. And I take the square root. When you take the square root of a variable squared on this side, what that actually does is whenever we get rid of that squared by taking the square root, it creates two answer sets so that I have a plus and minus for every answer. And it's going to work that way anytime your exponent is even. You're going to end up with two answers, a plus and a minus value. So now if I put a value in for x, say 2 minus 1, the square root of 1 is 1. So if I substitute x equals 2 in, it gives me plus or minus the square root of 2 minus 1, which is plus or minus square root of 1. And the square root of 1 is 1. So that gives me plus or minus 1, which means I have two solutions, positive 1 and negative 1. Since there's more than one solution, this would not be a function. And that seems like a good spot to leave off for today.